Okay, so let me start. Welcome to this chemistry session. Our focus today is on calculations in chemistry. So whatever questions you have, we'll try our best to answer those questions here in chemistry. So my goal is to make sure that you are very confident in solving chemistry problems. So the secret behind all chemistry calculations is knowing what you need to know first. Okay, so the atomic number, the mass number, or we call it the relative atomic mass. So I don't want to be, I wouldn't be calling it mass number. Please take note of that. There are two things, a big difference between mass number and relative atomic mass. Okay, so the relative atomic mass tells you about the average weight of the isotopes of that element. So if you get all the isotopes of the element and you add them together, you you get the actual weight. So the average weight of of those isotopes gives us the atomic mass. Then the mass number is just the addition of the number of neutrons and the number of protons. So that is not what we use for chemistry calculations. We only use that. The only time we use the mass number for calculations is when we want to calculate the relative atomic mass. Okay, so that is it. And then that is like what we have in this. So let's say, for example, the relative atomic mass of chlorine is 35.5. So how do we get this 35.5? It's very simple. So usually chlorine has two isotopes. So we have chlorine 35 and chlorine 37. Okay, so how do we write these isotopes? So maybe you've seen your teacher write 35 before, and then another one, chlorine 37. You can see that the mass number is number at the top of it. So 35 and 37 are the mass numbers. So that means if you are comparing the weight, so these two chlorine will not have the same weight. So the first one is 37, the second one is 35. So you discover that if you add up the weights together and divide it by the abundance, then you get the relative atomic mass. So that is the actual weight of an average atom of chlorine. So the question is, did I just say 35 plus 37? That gives us about 72. Then if you divide it by 2, that gives you 36. Oh, maybe I can approximate 35.5 to 36. No, that is not what we did. So what will happen here is that each of the isotopes have different abundances. So what we mean by abundances is in what quantity are these isotopes ever present in our environment. So some of them have very high abundance, or some of them are very, very few. So let's say, for example, chlorine 37 have a low abundance. We don't always find chlorine 37 around. So in either in a given sample, so you should have between 25%. That's quite high. So you have some isotopes that can go as low as 1%, 0.09%. Okay, so that is very, very true. They have chlorine 35, that's about 70% abundance. So if you want to calculate the relative atomic mass, all what you need to do is to multiply the abundance by the mass number and divide it by the total abundance. Okay, so the total abundance is usually 100 if we are looking at it in terms of percentage. Sometimes they give you the ratio. So maybe we have what we call mass spectrometer. So a mass spectrometer, it gives us it can help us identify various isotopic peaks or isotope peaks in a mass spectrometer and their ratios. So you can try to do the ratio of them. All what you need to do, if you want to calculate it using the ratios, so all what you need to do, multiply the ratio for each isotope by its mass number, just as we have percentage. At the end of the day, add everything you get together and divide it by the total ratio. So if we have questions, can we start sending them? Of course, right now. If you have questions, post them on the chat session and I would be answering them as we move on. Okay. So you don't need to keep quiet. Let's say, for example, we have here isotope. You see, oxygen has isotope 16, isotope 17, isotope 18. I'm sure you have never heard of isotope 17 before. Yeah, that's really very possible. So you have oxygen has isotopes, and one of them is 17. But for this question, we are only considering like isotope 16 and 18 because the isotope 17 is very, very so like the abundance is very, very less than 1%. So most times they don't usually bug you guys with that kind of questions with it. So the question is, how do we calculate the relative atomic mass of that isotope? Okay, I know you've seen that the way I solved it. So you just if it is in the exam, you don't need to suffer too much. Relative atomic mass is equal to so you say look at the word here respectively. If they say whenever you see respective, that means in accordingly. That means the first one has 60 isotope 16 has 90%, isotope 18 has 10%. So that's what called respectively. So if you want to do this, so you just do 16 times 90. I always put it in brackets so I don't get confused. I know why. Because when you're typing into calculator, you can just type everything straight in calculator, and your calculator will misinterpret whatever you're solving. So always put it in bracket. They have 18 times 10, put it in bracket. You can see how easy this is. What is the total mass, the total number, or the total percentage of the isotopes? 90 plus 10, that's 100. So just put 100 there. Okay, so that gives us a very easy way to, yeah, it's kind of easy, right? So 16 times 90 plus 180. So everything gives us like 16 points. So, okay, so that is the relative atomic mass of oxygen. Okay, in this question. So when the periodic table, they just give like 15.999. Remember I told you that acid oxygen has other relative atomic masses. So this is just with respect to this particular question. So don't freak out and say, oh, how come my periodic table is telling me 16 or 15.999? Okay, so that is, I told you there are other isotopes. Okay, that's very, very important for us. Okay, so now I use that one to introduce to you what we are really talking about. So I'm sure you see this kind of question. Another thing I need to point out to you that they can just say an element has two isotopes. The abundance of isotope A is 20%. Calculate you see that the abundance of isotope A is 20%. Calculate the relative atomic mass of this element. So they've already told you that isotope A is 20%. They didn't mention isotope B. They didn't tell you about its own percentage. So Mr. Nkwocha have told you that when you get to that point, all what you need to do, the total percentages must give you 100. So just do 100 minus the other one, and that gives you 80, right? So has that question ever come out before in my yes, of course. I think that was 2017 question number one. Also, 2017 question number one or 2016 or also. So when you open that particular WAEC, oh, come on, somebody's committed here. When you open the WAEC past question, you will see that's really, really present and pronounced. Okay, so that's fine. So let's say I talk about the backbone of every calculation in chemistry. So the backbone of all the calculations in chemistry is simply mole. If you want to understand any question in chemistry, all what you need to know, you need to understand mole. So as I'm going to relate to you, how important is this mole? Think about any kind of question you know in chemistry. It's all related. You can solve that question if you understand what mole is all about. So my job is not for me to kind of be defining mole for anybody. But in my simplest terminology, a mole is the smallest substance you can have. Like is a unit that we can use to compare the quantity of whatever we are having. So if you have one bag of rice, you can compare it to a mole. Okay. So you can compare 1 drum of water to a mole. Okay, so in chemistry we use mole very, very serious. So 1 mole of an element contains a fixed number. So I don't want to be so bugging you reading this slide. So you can just say 1 mole is equal to the Avogadro's number. 6.02 times 10 raised to the power 23. You see, that's very simple. That's all. You can just say if you are dealing with gases in any calculation that has to do with gases, you can deal with gases. You can if you have for volume, so you have 1 mole of a gas is equivalent to that 1 mole of a gas will occupy a certain volume, which is 22.4 dn cube. Okay, that's very simple. In fact, the 1 mole of any element or any molecule, or yeah, so I'm picking it that an element or a molecule, so we weigh the relative molecular mass. So let's say, for example, we have calcium. Calcium is number 20, that's the atomic number, but the mass number, the relative atomic mass. See, I don't have to be calling mass number. Relative atomic mass is 40. So you can say 1 mole of calcium, the weight is equal to 40 grams. You see, that is very simple. So if you say water is a compound, so H2O. If you add hydrogen 1 times 2 plus oxygen, so the molecular weight of water is 18. You can say 1 mole of water. So if you want to say the weight of 1 mole of water is equal to 18 grams of water. 1 mole of water, okay? 1 mole of water is equal to 18 grams. So you know that the way they usually do this comparison in math is say if A is equal to 6, A squared will be equal to X, right? That means if A is equal to 6, A squared will be equal to, of course, we know it's 36, but this is equal to X. So the moment you can express any of your problems in terms of mole, you have solved that question. In fact, if it is in Y and you express your calculation in terms of mole, you have actually solved that question. So here is just a summary of different ways you can relate mole. For UTME questions that has to do with stoichiometry, these are all the formulas that you're going to need to solve it. In fact, you don't need to. I don't like memorizing formula, but if you are good at memorizing formula, that's fine. But you don't need to memorize any formula. Okay, so like I said, let's just hope. Nowadays, UTME is CBT based, so either memorizing will give you an advantage, or learning how to calculate it also gives an advantage. So you have mass to mole, atom to mole, volume to mole, concentration. In fact, even for solutions, we also have them in mole. Okay, and these are like the basic ways you can relate it. So what I always do is that sometimes they will give you a question and they will give you information about the mass, and they're asking you the number of particles. So you can compare two equations and you'll be fine. Let's say, for example, you can make you can compare this one and this one. So you can just say mass over molar mass is equal to number of particles divided by Avogadro's number. You see, you can compare the two equations together because both of them expresses mole. You can say number of mass over molar mass is equal to volume of gas over Avogadro's number, over molar volume at STP. Very simple. You can compare any of these things together. So you can compare this one and this one, this one and this one. So any of the equations, you can compare them together and you'll be able to solve questions. So let's go to the serious nitty-gritty and see what really can we use to solve. Okay, so another formula that you can also remember is the empirical formula. Do you remember that this is like one of the easiest questions that where concepts in chemistry calculation that really? Is it under mole? Absolutely yes. In fact, until I realized that empirical formula is all about mole, I used to like try my best. You know, your teacher would say, first of all, there's this 5 steps that I usually memorize to solve empirical formula. No, 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 no. You don't need that. It's the same thing as mole. So we are going to see how we are going to bring those things together. Okay, so with mole concepts, you are fine. Okay, so let's pick empirical formula. I didn't know I was going to jam empirical formula first in terms of solving problems. Let me see. Okay, so let's play with this empirical formula a little before maybe in the future we can see more questions. So if you have any question, that is trouble, you can just type the question on the chat session and I will solve it right here. No, nothing to worry about. Okay, so let's see this first question now. Our element contains 40% carbon, 6.7% a compound, 6.7% hydrogen, and 53.3% oxygen. Now, yeah, solubility is also here, is at the bottom of this slide. As long as time permits us, we are going to do it. Don't be afraid. Okay, I got you. Okay, so this is very simple. How do you treat this in as mole? So what I'll tell you, you see how we are going to treat it as mole. Do you know we can convert this percentage to mole? Yes, that's the only thing you need to do. Com Convert everything to mole. So let's say you just write carbon, hydrogen, and oxygen. I'm dealing with number one question, so you can do number two on your own. So let's see their percentages. So here, carbon is 6.40%. All right, it's bad. So carbon is 40%. Um, Hydrogen is 6.7%. And then oxygen is 53. So how do you convert all these things to mole? Simply divide it by their relative atomic mass. When you divide it by the relative atomic mass, very simple. You are good to go. So what is the relative atomic mass of carbon? 12. So divide that by 12. It's always given. Hydrogen is 1, divided by 1. Oxygen is 16, divided by 16. Now, what we have just done here, we have converted each of those things to their lowest possible value in terms of mole. And when you have done that, even if they give it to you as masses, if they give this one is 5.3 gram of this, it's the same thing, convert everything to mass. I want to mole rather. Once I've converted it to mole, you just need to do their mole ratio. So I don't know if this is, let's say this is 3.3, this is 6.7, this is 3.3. You see? So all what we need to do is so let's do their mole ratio. Mole ratio means that you take all of them to their simplest ratio in terms of mole. Okay. So that means this you divide by the smallest. So this is divided by 3.3, divided by 3.3, and divided by 3.3. This is 1:2:1. And that is very simple. So your empirical formula will have C will be 1, hydrogen will be 2, oxygen will be 1. That is the empirical formula. You see, no memorizing. As long as you're able to deal with mole, you are fine. No memorize, do not memorize anything. You see, very simple. If you do this in WAEC or as why I'm saying telling you this is as fast as possible in JAM. So sometimes they will give you the questions will already be in mole. If you are doing JAM now, they'll give you an element contains a compound contains carbon, hydrogen, and oxygen. Because a compound contains 0.2 mole of carbon, 0.4 mole of oxygen, 0.6 mole of hydrogen. They've already converted it to mole already. Then I ask, what is the empirical formula? Come on, divide by the smallest mole. Yeah, and you're getting your mole ratio. Very, very simple. Don't don't fret when you get to the exam and you see calculation. Some people say, I skip all the calculation. No, 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 no. In fact, they are even easier to do. Okay, so because most of the time they've already converted it to more and they're helping you to save your time. Okay, so that's quite easy. Another thing I need to point out is, let's say for example, let me look at it. Let's say for example, after you found the mole ratio, I now discover that this is 1:2.5:1. So will I approximate this 2.5? Okay, somebody is requesting for him to record it on his own device. Yes, you can record it, so that will save you the pressure of downloading anymore, which is fine also. But if your phone doesn't have the memory, that's also fine. So if it is 1:2.5:1, do we approximate it to 3? Please don't approximate it. Okay, so do not approximate. What you need to do, multiply through. So let's say, for example, if it is 2.5, and then if you multiply by 2, it will give you 2:5:1. Absolutely. Just multiply everything by 2. to give you a whole number. Do not approximate. In chemistry, if you 2.5 to 3 is a whole lot of number, you cannot approximate in that way, okay? And then if you want to calculate the empirical formula, that means that originally, you see, this empirical formula shows us this simplest ratio. Remember, I said it's the simplest ratio. So what is now the actual way that the actual way that the elements can be present? The actual way the elements are present is what we call the molecular formula. So once you know the molecular weight, so the molecular weight, as we have here, that's usually called the molecular mass, tells us the actual weight of all the elements in the compound for 1 mole. So that means this compound, the actual weight, we don't know the total ratio we divided, we just put times n here. The actual weight is actually 180. The total weight of the compound is actually 180. So that helps us to find out what is the actual number of moles that we divided. What is the ratio of this division? So this is molecular formula, okay? So very simple. So we need to find what this n is. I introduce the n. So very simple, you just do 12, carbon is 12. So 12 plus hydrogen is 1 times 2, that's 2, plus oxygen 16. Everything in bracket n is equal to 180. So we need to find the value of that n. So n here is equal to 180 divided by 30, which is equal to 6. So you bring it back to this, our molecular formula now becomes C6H12O6. So that is like very simple way to do it. I know you are used to this. I don't have to waste much of your time. Let's move on. Okay, so if you have questions on empirical formula, you can use the other question to practice. Now, the only difference here is that in this one, I'm giving you vapor density. See, I will give you vapor density instead of molecular mass, just for you to know there that there's a relationship. So you can convert that vapor density to molecular mass using the formula at the bottom, and you are fine. Okay, that's easy. Let's move on. Empirical formula is not the main reason why I brought you here. Okay. Okay, so the other one is percentage by mass. A lot of time you see it in jam questions, and it's very simple. So if you want to say, oh, what is the percentage of hydrogen in this compound? What is the percentage by mass of this element? So you can use this formula. So you add up all the relative atomic mass, and that gives you what we call the relative formula mass. That's at the bottom. So if it is element, you can easily do that. I don't need to suffer you to be doing that. Okay, so back to the real deal. Yeah, this is the reason why I brought you. But where I told you that mole is everything you need to do. Okay, so look at this question. So they give you a question here, and they say you calculate the amount in moles of chlorine that will be produced from 5.1 gram of phosphorus pentachloride. Ladies and gentlemen, this is the reason why I brought here this kind of question. You see these questions in WAEC a lot, in JAMP a lot, and you'll be like, oh no, I'm not going to mess up. Because you are here today, you are guaranteed success. Okay, now, first things first, whenever you see this kind of equation or this kind of question that is related to an equation, check, is it balanced? So you are writing WAEC. So by now you must have learned how to balance chemical equation. So how do we balance it if you have forgotten? Make sure that all the elements, how many times they are on the left-hand side before this arrow, before this sign must be equal to how many there are on the right-hand side. So we have P, so you just have one P, that's phosphorus, just one of them here, on the left and on the right. And then we have 5 chlorine on the left-hand side. And that's how many? 3 plus 2 is 5. So our equation is balanced. Now, easy peasy, ladies and gentlemen, brothers and sisters. Once you get any question like this, I always tell my students, focus your attention on what they want you to calculate and what they give you as information. Now, they want us to calculate chlorine. See? That means an independent chlorine. And then they gave us information about phosphorus pentachloride. So which one is phosphorus pentachloride? Which of the which of them do we have? Are we talking about? So put the answer on the chat section. Let me see if you guys are following me. If you know which one is phosphorus pentachloride. Okay, so come on. 5, 4, 3, 2, 1. Ta-da! Okay, I got a response. Thank you guys. That's not the response I wanted. Yes, I'm recording it. Don't worry. I will still post the video. Don't fear about your network. Okay. Yeah, sorry about that. I understand. That's why I'm recording it because network is really bad in Nigeria now. Thank you very much for telling us that it's PCL5. Excellent. So PCL5 is what they give us information about. And then the one that they want us to calculate is Cl2, chlorine. So you're in the exam hall. Don't fret. Don't make any mistake. Just look at what the shortest cut you need to do. So since it is balanced, see what I'm going to do. I'll write PCl5 on my left hand side. I'll do ratio Cl2. You are in WAEC exam. Now you write what is the coefficient. If there were coefficients, write the coefficient. If it is 3PCl5 in a normal equation, just write everything like that. So look at what I'll just do here. I'll just say 1 mole of PCl5, it give us 1 mole, will give us, you see I mentioned will give us, and I wrote equals to. That doesn't make any sense. Equals to does not mean will give us. So if you want to say, what now should I use to represent will give me? I say 1 mole of PCl5 will give me here. So three lines will give me 1 mole of chlorine. So yeah, the moment you write that 3 lines, you have told the person marking it a white that you know what you are doing. Okay, so you cannot say equals to. It's not equals to, it's will give. Okay, so that's good. Now, so we have, from that equation, we have automatically said 1 mole. So that means the phosphorus pentachloride they gave us is in form of grams. So how do I solve this question? Using, remember our answer must be in mole. So one of the easiest things you need to do is to convert this phosphorus pentachloride diagram to mole. And the easiest thing you can remember in SS1 is number of mole is equal to mass over molar mass. Remember that we usually do it. Yeah, very simple. Mass over molar mass. Everybody remembers this in SS1. So now they gave you mass. So that means they give you 5.10 divided by molar mass. So we have chlorine is 5 there. So they have 31 plus 35.5 times 5. Okay. Very, very simple. So that is what you simply need to. So everything gives us 208. So that means you're going to have 5.10 divided by 208.5. So that is converting these grams to mole. So once you have done that, so you now do, so the number of moles is 5.1 divided by 208.5. So you now have 0.0245 mole is equal to X. So you just cross multiply, and your value of X is equal to 0.0245 mole of chlorine. That is very simple, like straight to the point. Very simple. Your answer is in mole, and you have solved it. I always tell myself, in how many lines? Just 1, 2, 3, 4. 4 lines. Yeah, I know that this is the extra bit of work we have to do. Yes, that's kind of easy peasy. If it is in WAEC, show your work. Even this one that I wrote by the right hand side there, still write it by the right hand corner of your answer script there. It is still important. WAEC will consider it. See, okay, so that's very simple. Okay, let's play around. Here, calculate the number of molecules of nitrogen gas. Oh my God. So they're giving you 2.8 grams of nitrogen gas, and they're asking you for a number of molecules. If you remember that one, yeah. And the nitrogen gas, you see, these people are very, very smart because they want you to be sure of what you're doing. Nitrogen gas. I hear they're giving us Avogadro's constant. So nitrogen gas means N2. You see, N2. Okay, so that's very simple. So remember what we always said. This is another shortcut I'm going to share. Yeah, I told you 1 mole is equal to 6.02 times 10 raised power 23 molecules. That's by Avogadro. You see, remember the same? Yeah. So I'm going to use second method. So you know what you're supposed to do, right? Very simple. Convert this 2.8 to mole. And that means you just go by the left-hand corner again. Let me do left corner. Find the molar mass of this compound here now. That's 14 times 2. So then convert it to mole. And that was so, so easy for you. Then you can now come back here and write your answer for me. Do it using the previous method I told you. I'm not going to use that method. I'm going to use the easy way when you're in the exam because you don't have time to be wasting. JAMB exam, not WAEC exam. WAEC exam, use that method I used to explain the first one to solve it. JAMB exam, you're in the exam. Oh my God, what do you need to do? You already know that nitrogen is 14 times 2, that's 28. So I will just go straight to the point. So I'll just say 28 grams of nitrogen will give you 6.02 times 10 power 23. Then I'll now do 2.8 grams will give me X. That's very simple. Yeah. Do you know why I use 28 grams? Of course, because I told you here that I remember that I told you 1 mole is equal to relative atomic mass. And the relative atomic mass of nitrogen is 28. And remember, I also told you that you can compare two of the equations, mass, mole. You see, I told you can compare two equations, mass, mole relationship, mole, atom relationship. Let's compare the mass, mass over molar mass is equal to number of particles, that's molecules now, over Avogadro's number. Let's compare these two together. So what is the mass they gave us in this question? 2.8 divided by what is the molar mass of nitrogen? 28 is equal to what is the number of particles? X, that's what they're asking us to calculate. What is the Avogadro's number? 6.02 times 10 to the power 23. If you solve this, if you cross multiply, you will get the same answer. Any way you go about it, you are on the right path. Okay, so that is how to play with those questions. Okay, so I've taught you 3 methods to solve this question. It's either you remember the formula or you remember the mole parts. Okay, or you convert these grams to mole and you are straight to the point. Okay, let's not buy time. This is another one. Uh-oh. Uh-oh. This is the one that you see in chemistry practical exam. And most of the time, students don't even bother solving it. Like, they just get to that point and like, oh God, have mercy, what is happening? Okay, so you write the balance. In this one, there are 2 ways you can solve it too. Write the balanced chemical equation for the complete reaction between H2SO4 and sodium hydroxide. That is easy. I told you this is like solving more question in practical wire question. So you just write H2SO4 plus sodium hydroxide. Thank God I wrote complete. See, chemistry there can be very, very funny. It's just like Ne2SO4 plus water. So I know it already so that I'm able to solve it. So just balance the equation. So, and you're fine. And I think I should have 2 water too. Okay, so that's easy peasy. Now, there are 2 ways to solve this equation. The question it says you can use the ratio method or you can use the formula method. On the right hand side, I'm going to use the formula method. Remember, I gave you one formula. Number of moles is equal to concentration times volume over molar mass. Okay, so very, very important. But this is crazy. You have to calculate the number of moles for sodium hydroxide. That is weird. So that means I have more things I need to do. That means if I can know the number of moles of acid, I can compare it to the number of moles of base. So I can, because they did not give me volume of base, they did not give me concentration of base, they did not give molar mass of the base. So I had, did I just say please, this formula is very wrong. I need to correct something in this formula before somebody watching this video will kill me. Okay, over 1,000. Okay, yeah, pardon me. The 1,000 there is to convert that centimeter cube, okay, to a standard unit. Okay, so that is very simple because we're dealing with volume. Okay, so that's converted like to liter. So that's a milliliter to liter. Okay, so that's or centimeter cube to meter cube. Okay, so all right, so that is very easy to do. So two ways to solve this question. If you ask me, I'm going to use the two of them. For you to solve this question, you must combine the two ways together. So let's use this. NAVA is equal to, remember this formula, CAVA that I used to play with over CBVB is equal to NA over NB. You remember this formula? Yeah. It's simply telling you here that number of moles of acid is equal to number of moles of base. It's very simple. Number of moles of acid is equal to number of moles of base. That is what this formula is simply telling you. And then the number of moles of acid is equal to concentration of acid times volume of acid. That's all. Number of moles of base, NB, is equal to concentration of the base times volume of the base. Very, very simple and straightforward. So all what I need here, I just need this one. So I think I need to just solve the whole thing using this piece on the left-hand side. So they gave information about number of moles of the acid. So I have volume of the acid, I have concentration of the acid. So that means with that one, I can calculate, if I know Na, I can use equally equal to Nb. So let's see. So let's use that formula, Na ratio Nb. So what is, from this equation, that's where you start from. What is number of moles of the acid in the equation? Coefficient of acid, that is not something at the back of acid, that is 1. Coefficient of base, Nb, 2. You see, that's very simple. Then that is from the equation. What about from the solution itself? What is our Na? That is CaVa. Okay, this is what I'm doing here. So say 20.20 cm cube. You have to convert it to dm cube. 20 cm cube. So divided by 1,000 times 0.125. Why? Because this one is in dm cube and this one is in cm cube. So that is that volume. So we need to make sure that the volumes are in the same place. So ratio x. That's number of moles. That's very simple. At the end of the day, you cross multiply this and this. So 1 times x is x. So you have 2 times 20 times 0.125 divided by 1,000. So you see, you have automatically solved that question because you recognize, that is the reason why they asked you to write that equation. You recognize that stoichiometrically, 1 mole of acid will require 2 moles of base. And that means that you understand that concept. Okay, so you can input everything into your calculator and let me just save it. Okay, 2 times 20 times 0.125, everything divided by 1k. That's 0.005. If you got that, your own answer, that's fine. Okay, that's number of moles of the base that is required that will completely react with that volume. Okay, so very, very simple. And it's only why that can bug you with this kind of technical question. Okay, so let's move on. Yeah, I like this question. This is another topic that you always see in JAMB, in WAEC. You always see this kind of question. Write the balance equation for the thermal decomposition of KCO3. You remember that equation that your teacher usually writes for you when they are producing oxygen in the lab? So they are producing oxygen in the lab. You use thermal decomposition of potassium trichlorate using manganese 4 oxide catalyst. So this is like MnO4, MnO2 catalyst. So just for you to remember, it's going to give us KCl and give us oxygen. I remember when you're in SS1, they usually use this equation to teach you how to balance equation. You just put 2 here, put 2 here, and put 3 here. Bear with me, I already know it before, so it doesn't matter. So now this equation is balanced. I would love you to deal with this, but I'll just explain it to you. It says if they are giving you 5.0 gram of KClO3. So this is very simple. Remember what I told you at the beginning of this class? This class. Compare. So they're giving you KClO3 and they want you to find oxygen. So oxygen is in volume. Hey, that is mass volume relationship. And KClO3 is in grams. Mass molecular weight relationship. So mole mass relationship. This one is mole volume relationship. So on my left hand side, we are doing mole mass relationship. On my right hand side, I'm dealing with mole volume relationship. This is so easy. So because of that, don't give up. It's so easy. Convert everything to mole and you are fine. You see? Convert everything to mole. That means convert this 5 gram to mole and convert the oxygen to mole and you are all good. So I'll just do 2 mole of KClO3. You see? Will give me 3 mole of oxygen. Very simple. You see, you don't need to fear anything. So I've brought it down to mole and you are all ready to go. So that means the volume, oxygen will be, convert this oxygen in terms of volume. They've already given you molar volume of gas is 22.4. So that is easy. Then they've given you this one for you to calculate the molar mass of KClO3. Okay, so you can easily calculate the molar mass of KClO3. Oxygen is 16 times 3 in the formula. Chlorine is 35.5 and potassium is 39. So let's add it together. 39 plus 35.5 plus 16 times 3. 48. Okay. So look at this. I'm going to convert it. These 2 moles is equivalent to 2 times 122.5 gram of KCl3. See, I've converted that moles now to gram. You see, I'm no longer going to be writing moles anymore. I've converted that moles to gram. 2 moles, that means 2 times 122.5 gram of KCl3 is the same thing. It will give us, I'm converting these moles to volume now. 3 times 22.4 DNQ of oxygen. I've done what I'm supposed to do. So in the exam, you must be very, very smart. And I know you guys are really very smart kids, so don't be afraid of any calculation in chemistry. Okay, so the next one is, this is still from the equation. I've not touched what they gave us. So the question is, what did they give us and what do we need? They gave us 5 grams. So you have the 5.0 gram. We give us, this we should find it, X volume. So it cross multiply. So this cross multiply with this, and this cross multiplies with this. Okay, let me just squeeze the answer inside here. So that means I have X to be equal to 3 times 22.4 times 5 divided by 2 times 122.5. So I've solved every other thing. Cross multiply and divide both sides by the coefficient of X. That's what I just did. So that gives us the value of X. So ladies and gentlemen, this could be like the hardest question you ever come across in everything that has to do with mole calculations, and I'm done with it. See, so if you're in the exam, this one, let me use that word, is the one that you should think about. Is in fact, that was what brought us to this thing. Any calculation. So every other calculation is probability. These ones I've just explained you will always come out in WAEC or JAMB, either in the objective part or in the theory part. Okay, so gas laws is beans. Solubility is also beans. Solubility too is also moles. Moles. Um, what do you call it? There's one that we talk about. Electrolysis, electrolytic calculations. Faraday's laws of electricity. It's still the same thing as moles. And we'll see it very soon. So once you understand this mole volume calculation or mole mass calculation or mole atom calculation or mole electricity calculation, no matter how what it is so super easy. Okay. I hope it was clear. So it's calculation and you need to practice more before you be able to master it. Yeah, it's the same thing with this. So you can balance the equation and you'll be fine. The same thing with this. And I don't want to bug you. Yeah. Finally, I was able to do something serious in my life yesterday. Just putting all these gas laws on one slide because I didn't make calculations. So yeah, this is sort of like for you to play around gas laws. So I don't need to be teaching you gas laws. I just need to solve your questions. Which of the gas laws do you usually not understand? Is it Gay-Lussac's law? Yeah, that's the one that's the one that you always see more in JAM. And then you see grams of diffusion. Yeah, those two. These are the ones. All those boys law and Charles law, they are baby things. Just I'll just tell you that. Let me give you one big secret. The only thing you need to remember in Boy's law and Charles law calculation is not even is this equation. I'm going to circle it. Let me circle it. The only thing you need to remember is this guy here. Can you see it? I'm circling it by the left hand corner. P1 V1 T1 divided by P2 V2 T2. Let me tell you, if you can remember, okay, P1 V1 over T1 is equal to P2 V2 over T2. If you can remember that formula for Boy's law and Charles law, that is equals for you are good to go. Like you are super guy. Yeah. So once you remember it, boom, you're ready. So you can let me show you how it works. Look at this bottom screen here. See this one now. Now let's say they give you volume and they give you temperature, and you are not sure if it is Boyle's law and Charles law. Just use this P1 V1 over T1 is equal to P2 V2 over T2. How serious can this man be? I'm very, very serious. Why? Anyone that did not give you is constant. Yes. So that means they gave us volume, they gave us temperature. That means pressure is constant. So what do you mean by pressure is constant? Pressure is the same on both sides of the equation. So all we need to do, cancel pressure, cancel pressure. P1 cancel P1. So you just do V1 over T1 is equal to V2 over T2 because we have already cancelled pressure. You see? You don't need to memorize. Yeah, from our screen, it's telling us that it's Charles law, so that's it. Nobody cares. Nobody will be asking which one is Charles law. It's constant then. So just make your substitutions and you'll be fine. But before you make your substitutions, remember that your temperatures must be in Kelvin. Your temperature must be in your temperature must be in Kelvin. So once your temperatures are in Kelvin, you can go ahead and make your substitutions. Okay? Very, very simple. I hope that's easy understood. If you have a question with respect to that, just let me know. Like I said, Boyle's law, Charles law, Avogadro's law is what we have been solving in all those mole mass volume relationship. That's Avogadro's law. Okay, so but the only one that usually pressures whole students on their neck is this Gay-Lussac's law and Graham's law. So let me see if I can get a question. Yeah. Okay, so from Graham's law of diffusion, they're only telling you here that if you have two gases traveling, gas A, let's say for example, oxygen and hydrogen. Let's see, that's a very good analogy. Oxygen, the relative atomic mass of oxygen is 16. That means oxygen weighs 16. Hydrogen, the relative atomic mass of hydrogen is 1. That means it weighs 1. So if both of them are running, which one do you think will run faster? Obviously, lightweight, paperweight. Paperweight guy, yeah, in chemistry. The lightweight guy will travel faster compared to the person that is heavy. Somebody will say, but if I throw one big stone and one small stone, which one will fall faster? Of course, gravity has come to play because gravity is influencing the big one. So when they are running, will gravity influence it? No way. You see? So that's the thing. So if you put them in a vacuum, The one that is lightweight will travel faster. So that's why I decided to show you here that the lower the molecular mass, the faster the rate of diffusion of that substance. And then you can calculate the rate by doing volume over time. That's very simple. Okay, so this is just like a summary thing for you to know. In JAM, they can give you these gases, chlorine, helium, oxygen, and methane, and tell you that you arrange it in order of increasing rate. That means they are going from the slowest to the fastest. So remember, it is based on their molecular mass. So you calculate the molecular mass of each of them. The one that is highest will be the slowest, and the one that is smallest will be the fastest. So I'm sure you can relate. Okay. Oh man. Okay, this is a very simple question. So they said 100. I've already solved this, so I just need to like explain this side, so which makes it easy and saves our time. 100 cent cube of oxygen diffused in 4 seconds. 5 cent cube of gas, why we don't know the gas, diffused in 3 seconds. Which one do you think should be faster? The one that diffused in 3 seconds. That may sound quite right, but have you considered their volume? You see? So you have to be very smart. So in the exam, it's not everything you just go ahead and solve. You can check. So if 100 cm of the gas diffused in 4, and the other one only 50 of them could diffuse completely in 3. That means it's slow. So that means when they are 100 now, it will be using like 6 seconds, possibly. So that means gas oil will most likely be heavier. So all you need to just, if you understand that technique, just go straight to the options. Check the one that is more than mass of oxygen. And if possible, pick your answer. That would be correct, most likely. But if you now have multiple of them that are more than 32, then that's a big problem. Okay, so back to what we are supposed to do. So all I need to do here is remember this formula. Okay, so once you remember the formula, all what you need to do, calculate the rates for A, rate for B, and I usually make my life easy. I just write out the formula. So rate is set as volume over time. So here, for rate of oxygen, I can do 100 over 4. That gives me 35 centimeter cube per second. Molecular mass of oxygen. This is where you as a student will most likely fail this question because you forgot that oxygen is diatomic. And the root is here, oxygen diffuse, that means it's a gas. Oxygen is diatomic. So the molecular mass must be 16 times 2, 32. So once you're able to do that, the rest is history. You can put everything inside this your formula and then you are good to go. Okay, so these are your formula. So make sure you invert. Okay, so I don't want to waste too much time because it's not really big like that. This is where you talk about Ige-Luzak's law. I'm kind of doing it every time. So 30 cent cube of a gas that's hydrogen, combined with 20 cent cube of hydrogen, of oxygen, to form steam in this equation. Which one is in excess? Oh my God. How do I know? They never told us anyone is in excess. But come on, chemistry people, now, wow. How now? How do we know? But yes, that is how we solve it. So what theory comes to our mind? It is called Gay-Lussac law of combining volume. And it simply says that when gases combine, they do so in simple ratios. Very simple. Okay. They do so in volumes for somebody who come and criticize. They do so in volumes, and these volumes are in simple ratio to one another and to the product. So that simply means here that you need to look at the equation very, very well. This is the simplest way, easiest way to explain it. So look at the equation. This is hydrogen. So let me write this. 2H2 plus O2 will give me 2H2O. So since all of them are gas, 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 and gas, so everybody is gas. So they can ratio each other. That means 2:1:2, since all of them are gases. So that means if I use 2 centimeter cube of hydrogen, I will require only 1 centimeter cube of oxygen, and I will also form 2 centimeter cube of water, because they say that when gases combine, they do so in volumes, and these volumes are in simple ratio to each other. So if I'm using 2 cm cube of hydrogen, I will need 1 cm cube of oxygen. If I use, that means that one is like half of it. So if I'm using 30 cm cube of hydrogen, if I use 30 here, 30 cm cube of hydrogen, that means I'm going to be needing only half of it. That means I need 15 cm cube of oxygen. And that means I will also form 30 cm cube of water, because that is based on the ratio. So in the equation, they gave us 30 hydrogen, 20 oxygen, and we only need 15 oxygen. Oops. That means 5 of the oxygen is in excess. That is true. So what is the volume of excess gas? So here, our first question answer is first question is answered because oxygen gas in excess. So how much excess oxygen do we have? We just do 20 minus 5. It give 20 minus 15 will give us 5 cm cube of oxygen. So the volume of excess oxygen is 5 cm cube. You see? So the question is, what is the total volume of the gaseous mixture at the end of the reaction? Oh my God, how do we do that? That was easy. So at the end of the reaction, we will have used up all the hydrogen, because they will have 30 of them will react with 15 of the oxygen completely. So they will now form Newton, and they are forming 30 of water. So at the end of the reaction, we will have formed 30 cm cube of water, and 20, and we will now be left with extra 5 cm cube of oxygen. That is the unreacted oxygen. So the total volume of the gaseous mixture at the end of the reaction will be 30 plus 5, which is 35. So when you're in jam hall, they can call it, what is the volume of the residual gas? So they're calling it another word that you need to remember now, residual gas. Of course. Okay, so that's the one thing they can call it, residual gas. Or they can ask you, what is the total volume at the end of the mixture? Now, I was solving jam. I was teaching one student jam person one day. Do you know what jam did? Those guys are very smart people. Maybe in the past they used to be smart, but nowadays they don't make the exam so easy. So one of the past jam questions, they now said, look at what they did. They said this oxygen and hydrogen were exploded in a tube and later cooled to room temperature. Yeah. And the solution, the system was later transferred to room temperature. They now ask you, what is the total volume of the gaseous mixture at the end of the reaction? That is crazy. They cooled it to room temperature. Wow. So what is water at room temperature, gentlemen and ladies? Water is liquid at room temperature. And that room temperature, 25 degrees Celsius. Yeah, that was 25 degrees Celsius. At 25 degrees Celsius, water will never boil. Come on, it is still be liquid. What about oxygen? The boiling point of oxygen is about 283 minus 283 degrees Celsius. That's the boiling point of oxygen. So that means at room temperature, that oxygen will have boiled. That would be the only gas that is there. So can you see how smart jam question can really be? Man, if you were in this class at the big, and your network cut you off, and you say, oh yeah, the answer is 35, and the 35 will be there, and then there is 5 there. You forget that they say they cooled it. Okay, so just always be aware of those kind of tricky statements. Okay, so I don't need to bug you too much with all this fallacy. All right, so let's move. So I think that takes care of Gilizato. If you have any question on Gilizato, like just send it on the WhatsApp chat, and I'll be glad to answer your question. Oh, these people that are requesting to join, they are joining late. See when they are requesting to join this lesson. Well, maybe I'll send videos to them, so that's fine. Okay. You can use this as your practice. You can, okay, let's look at this one. Okay, so let me just give you 2 minutes, should I, to see if you understand it. So what volume of hydrogen will be left over? Yeah. So this time around, they exploded 300 cent cube of oxygen and 1,000 cent cube of hydrogen in a sealed tube. So they didn't tell us they're cooling, so let's be mindful. So if they didn't tell us about it, so what do we do about this? Which one will be in excess this time around? So which one should be in excess? Obviously. So you do the same thing. Let me help you. I know that some people that are really good in math will be here. So you have, this is 2:1:2. So if they give me 1,000 hydrogen, I'll be needing 500 oxygen so that I can get 1,000 water. Unfortunately, do we have 1,000 of water? Yeah, thank you. Hydrogen. Do we have 1,000 of water? Of course, nobody cares about water. Do we have 500 cent cube of oxygen? No, we only have 300. So that means you cannot use. So if I have 300 here, that means I will need double it. I will need about 600. Okay, so that means I cannot use all the hydrogen. So the question is, how much will be left over? So we'll be leaving 400. That's 1,000 minus 600. That gives us about 400. Thank you. Okay, so what is the total volume at the end of the reaction? So that means you can play around that. Okay, so you can draw the answer on the chart if you know it. The total volume of gas at the end of the reaction, and you will be fine. Okay, so that should be like 1,400 for those of you who are still thinking. Okay, so that's beans. Yeah. Oh, I even solved it. So it's on the slide. Okay, we are switching gears. Ha, electricity. So ladies and gentlemen, I have a video where I've taught electrolysis and I've also taught this calculation in the simplest way you can also understand it, just the way we have been doing it so far. Because of this is 7-Eleven, like we are already running towards excess time. Should I upload this to YouTube for you to watch, or should I use 5 minutes, I wish that was possible, to teach these calculations? So uh, let us have your choice on the third session. Don't enter my- Okay, what do you think? Should we call it a day so I can go and do other things and I'll upload the video and send you the YouTube link? Dun, 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 dun. Come on, I'm waiting for you guys' response. So let's just get your response. Okay, I have one. Okay, upload on YouTube. Okay, that's fine. I don't want to rush you guys, but I want to believe that. Okay, so at the end of the day, I have prepared parameters of electrolysis and how it is uh, solved. Again, those formulas that you will need. You see, the same mole something is back here again. Okay, and then question and how you solve it, question and how you solve it. And I'd love to solve these questions, but I've already solved them. So let's hope that you will. And of course, solubility is that for that my friend I talked about. Solubility. Um, if you are looking for my videos on YouTube, just type the topic and put Mr. Nkwocha on YouTube. Let's say um Arcanes by Mr. Nkwocha. So you will see it. But if you're on the WhatsApp group, I usually post the video link. Come on, guys, you guys don't be selfish. Subscribe to my link now. Let me hammer. All right, so but I'm just chilling. So if I'm really, really excited about you guys a lot of people watched the video afterwards, and that made a lot of sense. So those of you that want solubility, I have the solubility formula and then some simple questions, and that's just like, and then if you are into this mass volume relationship, we are going to still continue it when we are dealing with chemistry practical calculations. Okay, so that is where we are going to call it a day because our time is fast spent, and I wouldn't want you to burn much of your data anymore. So just go online, watch the YouTube video, and make sure you tell your friends and neighbors, come on, join this free chemistry class. Not everything is free. And I'll be posting more questions for you to practice. And yesterday night, I posted JAMB past question. That is really, really on point. So at your fingertips, you can practice JAMB questions. Like I have about 8 years of chemistry JAMB past question on the YouTube. I didn't say on the WhatsApp. Is it the YouTube name? Oh man, let me see. Let me stop and then um let me uh I'm still sharing my screen. Let me stop recording.